Welcome to the electronics class for October the 19th. I've looked over the submissions that you guys did for last night's homework. Looks really good. Several of you had some difficulties getting the circuit to work. And so you and I exchanged emails and whatnot. And in some cases, it was pretty puzzling trying to find the mistake. But then once we finally found the mistake, we said, well, yeah, of course, it can't possibly work like that. We just didn't notice the mistake. So what I would like to do for the first few minutes of this class is to let you guys experience that same thing. I think there's a tremendous value in doing what's called troubleshooting. That's that's a skill that is very, very valuable for anybody who's an engineer or an electrician. You've got something that you've built and it should work and it just doesn't work and you've got to figure out why. That's called troubleshooting. So what I'm going to do right now is I'm going to share a circuit with you that I created because I didn't want to use one of your circuits because I didn't want you guys to be embarrassed. So I created this circuit, and in this circuit, I've duplicated several of the different mistakes that I saw from several different people. And when I show you this circuit, some of you are going to be tempted to immediately blurt out, say, oh, well, there's a mistake, there's a mistake. Don't do that. I want you to hold off for, let's say about 2 minutes and just make a list of all the mistakes that you see. And then we're going to go around and I am going to call on you. So I don't want you to blurt things out. I'm going to call on you. And if I call on you, I want you to be able to tell me at least one of them, well, just only one. There are lots of mistakes in this circuit here, but I want you to just pick them out one at a time. All right, so, okay, here is the circuit. And let me zoom in on it just a little bit more, make it a little easier to see. Okay, so this is a circuit that has 3 resistors in it. And so I've hooked up a multimeter here. And so the intention is that I want to measure the current that is flowing through this circuit so that I can compare it with, with what I predicted it would be. Now, when I start the simulation, so you see, I'm going to go up here, I'm going to start the simulation, and I'm getting 0. Oh my goodness. All right, so clearly something is wrong, and in fact, there are some things that are wrong. So I'm going to give you guys 2 minutes. I want you to look this circuit over and tell me what are the things that are wrong with it, but only when I call on you. Okay, so I'll start the 2-minute clock right now. Let's see what you can come up with. Isaiah is saying that it's so painful to look at. Yes, there are a whole lot of mistakes in here. Okay, so I see a few of you are trying to send me some private messages containing the errors, and you are correct. Those are some of the errors, but rather than sending me the private messages, just hold off, and then what I'll do is I will call on people, and then I want the people that I call on to unmute themselves. And then we'll just go through them one at a time, and we'll fix all the things that are wrong with this circuit, and then hopefully we'll have something working. But I want to work one at a time. Okay, hopefully now you've located a few. All right, so I'm going to start calling on people, but keep on working because there's a lot of mistakes in here. So let's see if you can catch them all. Lily, would you be willing to go first? Would you unmute yourself and tell us what is one and only one? Yeah, there's lots of them, but only tell me one mistake that you see in here.
the positive wire isn't connected to the positive thing on the breadboard.
Okay. All right. So Lily is saying that this positive wire right here should go up here. Okay. Now, oops, what's going on? That's really funny. What happened there? Oh, no, let's see. Why does it not want to go there? That's funny. Okay, let me just delete that. Let me just delete that completely. Now it won't delete. You guys see that? This is weird. I think I better refresh my screen here. But I think Tinkercad's gotten in some really weird mode here. Let me just refresh the screen. So I tried to move the wire and Tinkercad moved it, but then it moved it right back. And then I tried to delete the wire and Tinkercad deleted it, but then it brought it right back. Okay, so let's see if Tinkercad will work for me this time. Okay, good. All right, so Lily is suggesting that the plus wire should be there. Now, let me comment on that. So I agree that that is the better place to put the plus wire, but you don't have to do it that way. Okay, if you wanted to, you could put the plus wire down here. I mean, you could do it if you wanted. You don't have to put it up there. But if I put it in this group that I put it, Lily, can you see what's wrong with me putting that plus wire in that group right there? Besides the fact that that's not the recommended way to do it, there is also a really serious problem with putting it there. Can you see what that problem is, Lily?
It's not connected to like anything. Like
Exactly.
it's not connected to a resistor.
It's not connected to anything. So I had more than one person who submitted something where they had hooked up stuff like this, and it made me realize that they don't fully understand how breadboards work. Okay, so let me zoom in even more here. I want to zoom in really close. So when I hover my mouse over this hole here, you see how the thing that I'm hovered over shows up with the red square, but you'll see the other four circles there, they also light up. So what that means is that any one circle in this group of 5 is connected to the others. Okay, but only that 5. Okay, so if we come up here and I look here, so the red wire comes in here and it's part of that group of 5, but nothing else is connected to that group of 5. So the electricity comes into this group of 5 and then it can't go anywhere. So there are a couple ways to fix it. One way is to come up here, and because as Lily recommended, up here, this is the place that people usually hook their plus voltage to. But we don't have to. If we wanted to connect it over here, we could do it this way. And so that's what I'm going to do. Okay, so now the electricity can come in here. And so now the electricity has some place to go. So let's see if that fixed our problems. Okay, so let's come up here. Let's start the simulation. Nope, still got nothing. So although Lily did correctly identify one of the problems, turns out there are others. All right, so Henry, could you tell us what's another one of the problems?
Well,
Just one of them.
I'm pretty sure that the wires are not hooked up correctly to the ammeter over there, right? It's not. It's going into negative and coming out on positive. That isn't right.
Well, okay, I see where you're going. Now
Yes, both of them connected up to the same exact wire on the
that's
breadboard.
that's what I'm looking for. That's the more important thing. Okay, so the way I've got it right now is that both this lead here and this lead here, they're both connected into the same group of 5. So that's not the way that voltmeters need to work. One of these needs to be connected to one thing, and the other needs to be connected to a completely different thing. So right now, these guys are connected together in a way that has no hope of working. Okay, so what let's do is let's take one of these leads here. Let's take this one here, and let's connect him into a different row. Oh, I gotta stop the simulation. Tinkercad won't let you move wires around while the simulation's going, so I gotta stop the simulation. Okay, so I'm gonna move this guy into here, okay? Or actually maybe, how about there? And so I'm gonna have to move this over here. Okay, all right, good. Okay, so now if we trace the flow of electricity, which is something I recommend you get in the habit of doing, at least mentally. Okay, the electricity comes out here, comes in here, it can go to here. And now it looks like it's going through here. We're going to talk about that just a minute. So now it comes to here. So now it comes in and it goes in here, comes out here and goes down there. Okay, so now let's go to what Henry said at the very beginning. Henry was concerned about the fact that the electricity is coming into the red, I'm sorry, coming into the black and going out of the red. So Henry was bothered by that. Now, in reality, if you hook up the meter backwards like this, it doesn't hurt anything. It's just that what's going to happen is you're going to get a reading that has a negative sign in front of it rather than a positive sign. And that's okay. I mean, yeah, it's not the best, but it doesn't hurt anything. But I don't want Henry to be unhappy here. So let's go ahead and let's fix that. So let's take this guy and just temporarily move him down here. Take this guy and move him over to there. Take this guy and move him up to there. Okay, so now you can see the electricity now is going to be coming, it's going to be coming into the, oh, wait a minute. Yeah, okay, yeah, that's right. Okay, sorry, I was confusing myself. Okay, so it's going to come into the red and out of the black. Okay, so Henry's concern has now been taken care of. Oh, but there are so many more things that are wrong with this circuit. All right, Isaiah, can you find another thing that's wrong with this circuit?
So the resistor on the negative side, the very bottom of the breadboard, you can't plug it in right there. You have to move it on to the breadboard. So if you were to move it, see the little numbers on the breadboard, if you were to move it to 8 and 10, that would work, but you would have to connect the wires from like A2 to like, let's say A7. So because it can't flow vertically, the current only will flow horizontally.
Okay, very good. Okay, so he is absolutely correct in saying that there's a major problem right here. You might think that the electricity is going to come in here and go into the resistor, go through the resistor, and then come out the other side. That's what you might think is going to happen, but that's not going to happen because every dot on this row is automatically connected to every other dot. So this resistor might as well not even be there. What's going to happen is the electricity is going to come here and it's going to bypass that resistor completely and just going to flow right into here. There's no reason in the world why the electricity would go through this resistor because it has a short, can cut right through it. So this resistor might as well not even be there. All right, so Isaiah is suggesting what we need to do is we need to move this guy up to here. And then let's take this wire here and let's connect it to there. Come on. Okay, and then now we're going to need another wire coming from here, going down to there. Okay, so now let's trace the flow of the electricity, at least in that region there. Okay, so what's going to happen then is when the electricity comes out of our meter here, it's going to come there, go to here, go over to here. Now the electricity has to go through the resistor, so it will, and then it comes down here, and okay, good. All right, so this part of the circuit is looking much better. Oh, but there are still mistakes to be made. Okay, so let's see who we not picked on for a while. How about Simon? Can you find another mistake in the circuit here?
It's inefficient. The space usage is very inefficient. So if you zoom in on the top green line, there's like 10 spaces between them when you could compact it down to like 2.
Okay. All right, good.
It's
now,
not really a functional problem, but it's just a problem that bothers me.
Okay, all right, good. I'm glad to see that Simon likes to be efficient, and I would hope that you guys would all be efficient. Yeah, this circuit here definitely uses more wires than it really needs to. And some of the wires are longer than they need to. But those are not killer problems. Even though it's inefficient, the circuit would still work. And so I want to focus in on the killer problems, because right now, when I click on the start simulation, okay, well, now this is interesting. Okay, stuff is happening now, but not quite what we wanted. So there are still some more mistakes that need to be found. How about Presley? Can you find a functional killer problem with this circuit?
I'm pretty sure the resistor that is connected to J14 and F14 is similar to the one that was previously connected to the negative line.
Yes, you're absolutely right. This resistor right here might as well not even be here, because you don't want to go plugging your resistor. Let me zoom in a little bit here. Let's see, need to quit out of here. Okay, hang on a sec while I zoom in. Okay, there we go. Okay. This is similar to the problem that we had just a few minutes ago. This group of 5, all of those guys are connected to each other. So if I've got a resistor where one side of it is here and the other side is in the same group of 5, the electricity is going to look at that and say, why should I even bother going through the resistor? Because the electricity can go from here. Let me clear off. Electricity go from this point down to this point, bypassing the resistor completely, because this point up here and this point up here, they are connected together by a bare wire. So if the electricity comes in here, it'll just flow right through here, and it'll say, oh, there's no point in even bothering to go through that resistor. So the electricity is going to ignore that resistor completely. All right, so yeah, that's not good. So what we need to do is to fix that. So let's take this resistor here and let's see if we can, I'm going to disconnect these guys. Okay, so now hopefully I can move my resistor. Let's move him down to here. Okay, or how about over here? Okay, so now when the electricity comes in from above, it now will have to go through the resistor. And so now, okay, I'm thinking we've got something that's worked now. So let's see how the electricity is going to flow. So the electricity is coming in from here. It's going to go down to here. And so now the only place it can go is through the resistor. And then it goes up to here, and then it goes into the meter. Okay, so now Simon is going to be very unhappy with this because we got way more wires here than we really need. But functionally, it's going to work pretty well now. Okay, so let's back off here. Now remember, the reason I put this multimeter here is because I want to measure the current that's flowing through the circuit, right? So before I hit simulate, can anybody, let me just throw this out to anybody who can answer it. Can anybody see a problem with my multimeter? If I want to measure current, is it going to do the job for me?
No, it's going to measure the voltage.
Yeah, it's going to measure the voltage. Okay, you got to be careful with these multimeters here. Okay? If you look right here, you'll see that the V is the one that's highlighted, and that's not what I want. I want current. Okay, so let's fix that. So let's click on the multimeter and let's change it from voltage to amperage. Okay. All right. Let's see if we got them all now. Let's start the simulation. Okay, so I'm getting a number, but the number that I'm getting is microamps. That signal, the symbol looks like that, the U with the little extra tail on it, that's micro. So that means 1/1,000,000th of an amp. And so when you guys did problem number 6, you expected your current to be in milliamps. So if you're getting microamps, then that means that something seriously is wrong with this thing. But it's not the way they're hooked up. I think we got the hookup going pretty well. Let's see if we can figure out what's going wrong here. So let me click on a couple resistors. So
You've kind of been, you're muted.
my internet just dropped out for some strange reason.
Yeah, you were cutting out for.
Yeah, you keep
It's
cutting
been cutting out the
from-
entire time.
Yeah. Okay, is it better now? Are you still hearing me okay?
It's a lot better now.
Okay, good. All right. So let's suppose that this is a circuit that's kind of like problem number 6, where we calculated what the current should be, and we calculated the current should be some number of milliamps. And yet when we do the simulation, we're getting microamps instead of milliamps. So we're trying to figure out what's going wrong. So I click on this resistor here. Now let's suppose that this was a resistor that I wanted to be 350 ohms. So I click on it. It looks like 350. Is everything okay? Brian, what do you think? Is this 350?
350,000, yeah.
350,000, right. Okay, very good. Okay, so you got to be careful. This guy over here is going to bite you. And this happened to one student. They looked at the numbers here and they thought, oh, it's good, but they didn't realize that the number over here got switched over somehow, got over to kilo ohms, or maybe even it was mega ohms. I mean, you guys know that you got a lot of choices here. So if you pull this down, you can go to mega ohms. You can even go to giga ohms, which is billion ohms. Okay, so you got to be careful. Make sure this thing is set for ohms, not kilo ohms, unless the thing really is kilo ohms. This one right here, same problem. We may have wanted 275 ohms, but what we got was 275 kilo ohms. So let's fix that. And while we're at it, let's check this one. Okay, this one is 1 kilo ohm, which is 1,000 ohms. So if I wanted this resistor to be 1,000 ohms, hopefully you recognize the 1 kilo ohm is the same thing as 1,000 ohms. Okay, so I'm thinking we've got all the problems. So now we start the simulation and we're getting some number of milliamps, which is in the range of what we expected. So yeah, okay, so we now have a working circuit. Okay. This is something that you guys need to get good at, is at troubleshooting here. What I plan to do today is I'm going to spend the whole day just doing review. Next time we meet, we are going to take a test. If you guys have looked on Canvas, you've noticed I've had that item on there for about a week now. So on Wednesday, we're going to take a test, and it's going to be the final exam for this quarter. The things that are going to be on that exam are things that we've spent the last 2 weeks going over. So my intention today is I'm not going to introduce any new material, and I'm not even going to give you a homework assignment today. The homework would just be do whatever you need to do in order to prepare for this exam. So let's go over a couple problems kind of like you're going to see on the exam next time we meet. So one thing that I can guarantee you'll see on the exam is that there will be a circuit that you need to solve it using the simplification method. So let's do an example here. So let's say that I've got a resistor and it comes over here. Oh, I'm sorry, I'm thinking ahead of myself here. I've got a battery, okay? And so Caden, that's fine, don't worry about it.
What was that?
Sorry, Henry?
You cut off for a second. What was that?
Okay, so I've got a battery, and then here's a resistor, and here's another resistor, and then here's yet another resistor. Okay, all right. So let's suppose that I want to know how much current is the battery putting out. And let's put some numbers on here. Let's say that this is a 5.7 volt battery. Let's say this guy here is 125 ohms. let's say the guy on the left here is 350 ohms. Let's say the guy on the right is 275 ohms. Okay, and so I want to calculate how much current the battery is going to be putting out, and I want you to use the simplification method. When I do the test, when I write the test, I'm going to insist that some of the problems have to be done using the simplification method, and other problems have to be done using the Kirchhoff's method. Okay, so I'm going to sit here quietly for about 2 minutes, and I want you guys to work on this, and let's see what you come up with. When you get an answer, don't type it into the chat box in a general message to everybody. Type it in using a private message only to me.
Wait, what exactly are we trying to find again?
The current that the battery is putting out.
Okay.
It says we can't chat with you.
That's weird. Let me see why that might be. My screen, the settings say that you can. Can somebody else try chatting with me?
Mine says that I can't either.
That's really weird. Okay, let me go in and I'm going to disable this thing, and now I'm going to re-enable it. Okay, see if that worked. Can you try chatting with me now? Ah, okay. Now it seems to be working. Okay.
We don't need to know matrix math for this one, right? Because we're only trying to find one current thing, right?
Okay, yeah, you are correct in that you don't need matrix math. Also, I specifically said that I wanted you to use the simplification method here. So the matrix method only works with Kirchhoff's method.
I mixed up the names. Sorry.
Okay, all right. Now, it is possible to solve this using the matrix method, but I want you to prove to me that you know the simplification method. All right, so I'm starting to see some numbers now. And the encouraging thing is all the numbers I've seen so far have been the same number, so that's good. But I still need to see more. Keep on going. I need to see more numbers than just the few that I'm seeing.
Yeah, I can't chat with you either.
Other people are able to chat with me.
Yeah, I don't know.
Try getting out of private. So you need to switch it to everyone and then switch it back. That's what I did.
Ah, okay.
Yeah, that worked. Appreciate it.
Okay. Well, that's good. I've never seen that bug before. It's good to know about. Okay, one of the numbers that I just saw is different. So tell you what I'll do is I'll send a private message to that one person. Okay, so I just sent a message to that one person whose answer is different from everybody else's. Now, it could be that that one person is the only one who's doing it right. It could be that everybody else is doing it wrong, but it's not likely. Some of you are still not typing in numbers. I'm a little bit worried. So if you haven't yet typed in a number, what I'm thinking is maybe after everybody else leaves the class today, those of you that are having trouble doing this, let's you and I talk after class, after everybody else has left. Okay, all right, so I just saw another number that's different. So tell you what, let's start doing this one together here. So Eric, would you be willing to talk us through how to solve this problem?
Yeah, sure. So first of all, to use a simplification, we have to combine the two branches.
Okay, so what I think I hear you saying is you want to combine these two guys together first.
Yeah.
Okay, I agree with that. Okay, so if I start with my semi-simplified circuit, then this is what it's going to look like. So the battery
Yes.
is still 5.7, and this guy up here is still 125. But this guy here is the equivalent of these two.
Mm-hmm.
All right. Okay, so tell me, how did you calculate what the value of this guy is?
I did 1 over 350 plus 1 over 275.
Okay, and then you're saying that you did, because you know that's 1 over our total, so then our total is 1 over all of that.
Mm-hmm.
Okay, good. And what number did you get?
I got, let me check. I got 154 ohms.
154. Okay, and let me just make sure that I get that. So 1 over 350 plus 1 over 275, and then 1 over all of that. So yep, I get the same number. Okay, Jasper, how would we go to the next step?
You would divide you divide volts by the total amount of resistance.
Okay, so I agree with what you're doing. You've skipped a step, and you did it in your head, I'm sure.
Oh, you have to
because
add
thought it was
both of
three-
them.
Yeah. Okay, so what I like to see is I like to see a picture that shows the final fully simplified circuit that has one battery and one resistor. Okay, so what we're going to do is we're going to combine those two guys together into here. And so Jasper, are they connected in series or in parallel?
Series.
All right. So you're saying we can just add that, right?
Yep.
Okay, and what did you get when you add them?
I got 279.
Okay, is somebody in pain?
No, somebody's just being annoying.
Okay.
My sibling.
Oh, okay. All right. Okay, so Jasper, you're saying now we can use Ohm's law, right? So I equals V over R, which is 5.7 divided by 279. And what number did you get there, Jasper?
I got 0.02043 or 20.4 milliamps.
Okay. All right. And so if we move that over 1, 2, 3, so 20.4 milliamps, actually 20.43 something or other, but okay, very good. All right. So that is the simplification method, right? Now, what if I want to solve it using Kirchhoff's method? Could I solve this using Kirchhoff's method? So let's see, how about, who have we not picked on? Tristan, haven't picked on you yet. Okay, so if I want to solve this using Kirchhoff's method, how would I do that? Worth calling Tristan. Come in, Tristan.
So we could say, so first we could make our starting point before we cross over the battery.
Okay, I like that. Okay, right there.
Yeah. And then we're gonna cross over the battery and add 5.7.
Okay.
And then we're gonna keep going and we're gonna cross over the resistor, and that's going to take away 125 times the current.
So let's call this I1. Okay.
And then let's turn right and go over the 350 ohm resistor, and we could say it's minus 350 times I2.
Okay.
And then we can go back to our starting point and say that it's all equal to 0.
Okay, very good. All right, so I see an equation Oh, but rats, it's got two unknowns in it. That's going to be a mess. All right. So how about, let's see, Dallas. Where can I get another equation from? Earth calling Dallas. Come in, Dallas.
Oh, sorry, I didn't hear you there. You lagged out for me there for a second. What did you say?
So I've got an equation right here. And I'd like to just go ahead and solve it for the current, but I see two currents in there. And so if I got two currents, if I got two unknowns, that means I need two equations. Where can I get another equation from?
From the other resistor.
Okay, so can you be, so walk me through, how do I go through and do Kirchhoff's method?
You just go through do the same exact thing you did with the same stuff there, but with the other one there.
Okay, so I'm going to start here, all right? And you tell me what to do and I'll do it.
You get petrified out now. I forgot it.
Well, we're going to do this together. So the idea with Kirchhoff's method is we go around a loop so that we end up where we started from. Now, if we want to get a different equation, we're going to have to go around a different loop.
Yep.
Okay.
So you have to get there to the resistor that has 275 ohms instead of 350.
Okay, so I got to cross over the battery first, right?
Oh yeah.
So what's going to happen then? Am I going to gain or lose voltage?
You're in a game.
Okay, so I'm going to gain 5.7. Okay, now what do I do here?
You go through the 275 ohm resistor.
Whoa, wait a minute. That's way over there. I'm still up here.
I mean 125.
Yeah, okay, so I got to cross over the 125.
Yep.
So the voltage that I'm going to lose is minus 125 times whatever I1 is. So now I'm here. So now what do I do?
You head through through the 275 ohm resistor.
Okay. So I'm going to lose
the battery.
So 275 times I3 is that's the voltage that I'm going to lose.
Yep.
Okay, so now I can get back to the battery. Okay, good. So now I have two equations. Life is good, right?
I think.
Well, here's an I1, here's an I2. When I got my second equation, look at that. I got a third equation. I got a third variable. Rats. So now I've got three unknowns. Oh my goodness. So I've got three unknowns. That means I need three equations. So how about Brandon? Where am I going to get my third equation from?
You take, I think it's something like I1 equals I2 plus I3.
Yeah, but let's not just guess. What we do is we look at a junction. Oops, I hate it when I do that. I was still in erase mode, not write mode. Okay, so let me rewrite those things in there. Okay, so what we're going to do here is we're going to look at a junction. Let me clean off some of this. Okay, so we pick a junction, any junction. Oh, and by the way, okay, so there we go. Pick a junction, any junction. So whatever current is coming into the junction has to equal whatever current is going out of the junction. So don't just blindly memorize that I1 equals I2 plus I3. That won't always be the case. You got to look at every picture uniquely. Okay, so if we look at this junction, what current is coming into the junction there, Brandon?
I1.
I1. And what current is, so that has to equal the current that's going out. So what's going out?
I2.
And
then I3.
Okay, good. All right, so there's our three equations. Okay. All right, now, these are three messy equations. So if we're going to use this method here, if we're going to use Kirchhoff's method, I'm thinking we're going to have to use matrices in order to solve this. So clearly in this case, the simplification method would have been faster and easier. But I want you to prove to me that you know how to use Kirchhoff's method, and I want you to prove to me that you know how to use matrices. Okay, so I'm going to have to clear a little room here so that I can finish this problem up. So what we need to do is we need to take these equations and we need to put them in standard form. Let's see, Owen, if I were to take this equation up on the top here, how would I put it into standard form? What would it be in standard form? Remember standard form? Standard form says something times I1 plus something else times I2 plus something else times I3 equals something that doesn't have any i's on it. This right here, this is standard form. So we need to take this equation up here. We need to rearrange it so that it's in standard form. So Owen, how would I do that?
I think that you would start off by subtracting 5.7 from both sides.
Okay, I like that. Okay. Okay, good. So then we're going to have negative 125 times I1 minus 350 times I2. Now we have to do plus something I3, but there are no I3s in here. So how do we handle the I3s if there aren't any I3s?
You would just make it 0 times I3.
Very good. Okay, and then over on the right side, if we subtract it off of 5.7, we're going to have negative 5.7. Okay, very good. Thank you, Owen. Okay, how about Jasper? How would I take this second equation here and convert that into standard form? What would I have to do?
You would subtract I1 from that side.
Okay, subtract an I1 from this side. All right. Okay, so then...
I can't hear you right now.
You can't hear me? Okay. All right, I'll just go ahead and talk. So,
One
so
second.
now it looks like we're going to have negative 1 times I1, because remember, if you have I1, that's really negative 1 I1, and that's okay. And so we're going to have a plus I2 and a plus I3, and there's a 1 in front of each one of those. And then we don't have anything else on the other side here, so that's going to equal 0. Okay, very good. Now it's a little bit messy here. Let me see if I can make it slightly less messy, but okay, so we got negative 1 there, positive 1 there, and positive 1 there. Okay, Lily, how would I take this bottom one here and put it into, oh, by the way, there's an equal 0 at the end of that. Okay, how would I take this bottom one and put it into standard form?
You got to move the 5.7 to the other side.
Very good. And so I'm going to subtract a 5.7 on each one. Okay, so I'm over here, I'm going to have minus 5.7. Okay, so now I'm going to have negative 125 times I1. Okay, and I don't see any I2s there, Lily. So what should I do when I write the equation here if there aren't any I2s?
0 I2.
Okay, 0 I2. Okay, and then for I3s, I got negative 275 times I3. Okay, and that's going to equal negative 5.7. Okay, good. So I've got my equations now in standard form. I'm thinking the hard part is done. As long as I have a calculator that can do matrix math for me, the hard part is done, right? But some of you don't have calculators that can do matrix math, but you do have Desmos, right? Okay, so let me write this down real quick, because when I go to Desmos, I'm going to lose this. So minus 125. Actually, before I open up Desmos, let's write down what the matrix is going to look like. Okay, so how about Caden? Oh, Caden's not here anymore. Simon, what is my A matrix going to look like? Simon, you there? Hello, Simon.
Yes, sorry.
Okay. So what's my A matrix going to look like?
I don't know.
Okay, well, now's a good time to learn. So the A matrix is what we call the coefficient matrix. So Simon, what is a coefficient? If I've got an equation like, let's say I've got 2x plus 3y equals 7. So Simon, what is the coefficient of the x term?
It's a multiplier.
Yeah, the number in front of the x.
Yes.
So what is the coefficient of the x term?
2.
2. All right. So what I want you to do, Simon, is I want you to take the coefficients of the I1, the I2, and the I3, and just tell me what they are. So look at the first equation. What is the coefficient of the I1 term in that
Negative
first?
125.
Okay, so negative 125. What's the coefficient of the I2 term?
Negative 350.
Negative 350. And what's the coefficient of the I3 term?
0.
Okay, don't say 0, say 0.
Well, it's hard to read it.
Yeah, I admit that. Okay, good. How about Presley? We're back to you. What is the next row of my A matrix going to look like?
From what I can tell, it will be -1, then +1, and then another +1.
Okay, good. All right, Dallas, what is the last row going to look like?
I don't know.
Okay, Dallas, look at the last row. So look at this row right here.
Yep.
What is the coefficient of the I1 term? What is the number in front of the I1?
125.
Positive or negative?
Negative.
Yeah, don't forget that negative. That'll kill you. Minus 125. Okay, Dallas, what is the coefficient of the I2 term?
Is that 6?
Nope.
Okay.
It's actually that was it. Let me try that. Is that better?
Oh, that's a 0. Yeah.
Okay. All right. What's the coefficient of the I3 term?
Mr. Hendricks, you're
Yeah.
Negative 275.
Negative 275. Simon, you had a question?
Oh no, you just kind of stopped working for a second, like couldn't hear you or see you.
Okay. All right. So now we've got the A matrix. The A matrix is all of the coefficients, right? Now the B matrix is all of the guys over on this side. All right. So Luke, what are the numbers in my B matrix going to look like?
So you're gonna have a row, 3 rows of B matrix, and the numbers are gonna be -5.7, 0, and then negative. Is that a 5.7 or is that a 57? I can't
Yeah,
tell.
that's a 5.7.
Yeah, it's and then
Okay.
5.7.
All right, so this is my B matrix. Okay, so now it's time to call on the magic of matrix math. All right, so let's go up here and let's share a different screen now. Okay. Let's open up a new tab here and let's go to Desmos. Now I want everybody to do this. Everybody go to Desmos. All right. And then once you get to Desmos, go to Math Tools and go down to where it says Matrix Calculator. All right. And then we want to put in a new matrix. And I want you guys to do this. Don't just watch this. I want everybody to do this yourself. So when you click new matrix, it gives us an A matrix, but it's got 2 rows and 2 columns, and that's not what we want. We need one that has 3 rows and 3 columns. So Isaiah, what do you recommend we do?
So what we would do is we would take our first equation, which should be -125
Okay, hold on,
I1.
Isaiah, we got a problem. Before we put numbers in, the A matrix that I have on my screen here, when I hit new matrix, it's only got 2 rows and 2 columns. That's
Oh,
not
we
gonna
gotta
do
make
it
them
for me.
bigger.
Yeah, how
Just
do we do that?
hit the plus sign on the edit matrix A on both
Okay.
rows and columns.
Okay, now we're
And
in
then
business.
you can do the same thing for the B matrix if you want to
Okay.
get rid of it.
All right, so now what, let's see, so Lily, what numbers do I put in here?
One second. I can't remember the numbers, if I'm
Okay.
honest.
All right, so you guys should be taking notes here as we go along. You should be writing stuff down in your notebook. So let's go back here. Let's go back to the whiteboard. Okay, here are the numbers here. Guys, write this down in your notebook. So over on the left side, that's what the A matrix should look like. And then below that, that's what the B matrix should look like. I'll give you guys 30 seconds to write those down in your notebooks. And then tell you what I'm going to do. I am going to leave this screen up. I'm not going to go to my Desmos screen. I want you take these numbers and put these numbers into Desmos.
Hey, Mr. Hendricks.
Uh-huh.
For on the end of your equations, you have -57, not -5.7.
There you go. Is that better?
Oh, thanks.
Okay. All right. So put these numbers into Desmos, and then remember the magic phrase that you want to put into Desmos is A inverse times the B matrix. Okay, that's the magic phrase. So I want you to put that. So here's your A matrix. Here's your B matrix. Put it in Desmos, type A inverse times B. And then once you have an answer, I want you to type into the chat box, what numbers do you get for I1, I2, and I3? And I see that one person is way ahead of us. One person's already got some numbers in here. That's good for you. Okay, so somebody just sent me a number, but I need 3 numbers. I need to know what is I1, what is I2, and what is I3. So don't just send me one number, send me 3 numbers. Okay. Can you send me all 3 numbers in the same row, please? If you send me one number and then a few minutes later you send me another number, I can't keep those straight because numbers are popping up on my screen like crazy. So in one line on the chat box, tell me I1 equals this, I2 equals this, I3 equals that. Do it all in one line on the chat box. Okay, I'm seeing some numbers now. Okay, good. I see that some of you are converting it into milliamps, others of you are just leaving in amps. That's okay. That's okay. That works. Okay, now most of the numbers that I'm seeing that the number that you're giving me for I1 is 20.4, which I recognize from our previous work is the correct answer for I1. And so if that one's right, then that gives me high hope that I2 and I3 are right too. But some of you are sending me numbers where you don't have 20.4. Yeah, so yeah, guys, if you leave out a minus sign or you get things out of order, that will definitely mess things up. Okay, so I'm seeing enough answers that I think let's go through it now and do it ourselves. Okay, or do it together. Okay, so for the few of you who didn't send me answers, I'm guessing the reason you didn't send me answers was because you didn't know how to do this. Watch closely what I do. So I'm going to take the A matrix, which was 125 tab, and by the way, that's negative 125 tab, negative 350 tab 0. And then the next row is negative 1 tab, positive 1 tab, positive 1. Oops, that's not. Okay, so negative 1 tab, 1 tab, 1 tab. Okay, and then the last one is negative 125 tab, 0 tab, negative 275. Okay, so that's my A matrix. Now I hit return, so it stores it. And now I want my B matrix, but I need a 3x1, so I got to go and change it that way. Okay, so negative 5.7 tab, 0 tab, negative 5.7. And I hit enter. All right, so the magic phrase is A inverse times B, and voila, there is my answer. Okay, and the three numbers that you see there, the first number up on top is going to be whatever was the first number in our sequence. So that's going to be I1. The second number is going to be I2. The third number is going to be I3. And so you can see that I1 is in fact 20.4 milliamps. So that's reassuring. So if that one's right, that means the other two are probably right as well. Okay. So guys, if you don't know how to do matrix math, you will not fail the test, but you won't get 100. Because I guarantee at least one of the questions on the test, you're going to need to use matrices. But if this matrix stuff is just a little bit too much for you, don't worry, you can still pass the test without the matrix stuff, but you got to know the simplification method and you got to know Kirchhoff's method. Okay. I think that's a pretty good review of what's going to happen next time. So everybody understands next time we meet Wednesday, there is going to be a test. You will need to take it during class time. And I'm going to do it a little differently than I did in past. I'm going to make you turn on your cameras so that when you take the test, I need to see you. I'm being told that that's the way other Ames teachers are doing tests. And so I'm going to do it the same way. So when you log on next time, make sure you have a camera because I'm going to need that on so that I can watch while you take the test. All right, so you don't have a homework assignment tonight other than just do whatever you think you need to do in order to prepare for the test. Any questions before you guys leave? I see a few of you are leaving already. Okay. So you can go ahead and type bye in the chat box. I'll see you. Now, those of you that are having trouble, stay online. I'm going to turn off the recording so we can talk without it being recorded. And so those of you having trouble, let's talk this together. Okay, so here goes. I'm going to turn off the recording.